snap, it's already recording. Okay, so moving on to number 58. So this one, we're looking for the minimum and maximum again, and because it's not negative, we can assume that the graph, well, this is not accurate, but we can assume that the graph opens upwards. So we're going to have a minimum point down here. So we're looking for that vertex. Lucky for us, this is in vertex form already, and you can tell because it has the parentheses x plus 2, and then in the parentheses squared minus 1. So this is our h value and this is our k value. So that means that when we're writing our vertex, the coordinates will be at -2, because insiders lie, right there, it gave us that answer, -1. And if you go ahead and graph that, if you would like, I already have, so I don't make 2 videos again for one problem. I've already graphed this, and that is actually correct. So it gave us our vertex, and literally that's all we need. You can go on to get the roots and the y-intercept if you want. I mean, it's not necessary because we don't have to graph it, but if you wanted to, go ahead. But I'm just going to show you the easy way because that's all we need. So, sorry, I'm trying to focus this camera. Now what we're going to do, so we have our vertex. In the last one, we cut the graph in half at our vertex, and we created a line of symmetry. And oh my goodness, and we created a line of symmetry, and we said that this part is decreasing, this part's increasing. So we need to tell where the graph is decreasing and where the graph is increasing. I think it also asks for what else does it ask for? Oh, the minimum, maximum, and then where it's decreasing and increasing. Sorry. But like I was saying, so for this one, we can tell, this is just a little sketch, but because we know that the slope opens upward, we know that the value of this right here, it will be -infinity. This can be infinity. And if you don't understand, just leave it in the comments below. Make sure to subscribe. But we know that this point is at -2, -1. So we are looking for where the line of this quadratic, this line right here, decreases and where it increases. So if we cover this part up, that side, we can tell that this right here is decreasing. The line's going down. So we can say that from this point, this coordinate, or we could say from -infinity to this point right here, the line is decreasing. So I'm going to go ahead and say decreasing. And in interval notation, the way we would put this is, I feel like I keep misspelling decreasing. But in interval notation, we'll say that any number x that is greater than infinity, any number that is greater than infinity, or if we could say it like this, infinity, no, I'll just say it like this. Any number that's greater than infinity, but less than, any number that is less than -2, because we wouldn't do -1, because, I mean, you're asking where it's decreasing. So if we're looking at this on a number line, I mean, I guess you can do it -1, but we're just going to do it. We're just going to use the x value in this case, because you can clearly see with the horizontal line that this value is decreasing. So any number that is greater than infinity, but less than, any number less than -2 is decreasing. We're saying that any number on any point on this line, any point on this line that is less than, any point that is less than -2 and greater than infinity, any point that is less than -2, so that means from this side on, but greater than infinity, which is infinite, on this graph is decreasing. So that means we could just flip it around and write increasing down. What would you win? How much? Wait. Let me see.
Number 2?
Number 2.
Number 2.
Number two. $50. My dad won $50 in the lottery. 100,000. You'd be a lot more happy.
$50.
Okay. So, where was I? Oh yeah, sorry. Awkward. I should have just paused. But back to it. So now increasing. We want any value from this point on that's increasing. We can tell that the graph from this point on, the line is increasing. And we can use a vertex because we can't say that any point from this, like say we put a point right here. We can't say that any point from here on is increasing because you still have a decrease. But we know that at the vertex, it's increasing only. So we can say that x, when any number that is greater than -2, any number that is greater than -2, but less than infinity, oh my goodness, I forgot that negative infinity. But any number that is greater than infinity, that's not an infinity sign, is increasing. Does that make sense? Leave it in the comments. Make sure to leave a like and subscribe.